In our last video, we looked at how we construct a frequency distribution. In this video, we're going to talk about two other kinds of distributions that are similar to that are based on frequency distributions or built off of the information that we glean from that. And then we're going to talk a little bit about how we can look at a frequency distribution and determine whether or not it looks like it's a normal distribution. But let's look at two other types of distributions that we might have, that we might construct. So one that we might construct is a relative frequency distribution. So for a relative frequency distribution, instead of having a frequency column, we use the relative frequency. And what is a relative frequency, or how do we calculate that relative frequency? Well, the relative frequency is the actual frequency divided by the total. So in the last video, we constructed a frequency distribution for this hot dog data set. I'm going to extend it a little. Typically, you would not put both of these on the same distribution, so we can see how these things are related. I'm going to write this here. So for our relative frequency, the total number of values that we have is 20. So our relative frequency for this first class is going to be, it has a frequency of 1 divided by 20. As a decimal, that's 0.05. As a percent, that is 5%. So you might write this as a decimal or a fraction or a percent. The next one we would have 2 out of 20. So that 2 out of 20 is 0.05. Nope, sorry. It's 0.1 or 10%. We'd have 3 out of 20, which is 0.15 or 15%. 6 out of 20, which is 0.3 or 30%. 1 out of 20, which we found above, was 0.05 or 5%. 3 out of 20, which is 0.15 or 15%. And finally, 4 out of 20, which is 0.2 or 20%. Now, if you've done this right, these numbers here in this relative frequency column, those values should all add up to give you 100%, or if you're looking at either the fractions or the decimals, when you're adding those up, they should add up to 1. So that's a relative frequency. We could also do something instead of a relative frequency. We could construct something called a cumulative frequency distribution. So here we use the cumulative frequency. And so that cumulative frequency is simply the sum of the frequencies up to the class, up to the current class. I guess And again, let's go ahead and see if we can do this up here. I'm going to extend this distribution just a little further. Again, so we can kind of see where those things are coming from. So here, up through 121, the upper class limit of our first class, there has been a frequency of 1. So cumulatively, there is 1. Up through 133, the upper class limit of the second, we have these two plus we have the 1 from before, so we've cumulatively had 3. Up through 145, we have these 3 new ones, plus all of the ones that we had before. We had 3 from before, plus the 3 new ones. Gives us a total of 6. Next, up through 157, we have 6 new ones, plus the 6 we had from before. We now have 12 that we have seen cumulatively. Up through 169, we pick up 1 new one, which is plus the 12 we had from before. It's 13. Up through 181, we get 3 new ones, plus our previous 13 gives us 16. And up through 193, we now pick up 4 more, which gives us a total of 20. That makes sense because we had a total of 20 values, so by the time we get to the end, we should have all 20 of those represented in one of those classes. So that very last class should have cumulatively found all of the values. Perfect. So again, those 2 extra columns that I added on there, we wouldn't typically put those on all this stuff on together. We would usually take and replace this frequency column with maybe the relative frequency column, or we would replace the frequency column with this cumulative frequency column. The one other thing that we have is thinking about normal distributions. This will be our first look at normal distributions. Properties of a normal distribution. The frequencies, they'll start small. Then they'll increase to 1 or 2 large values. And then decrease back to a small frequency. The distribution is approximately symmetric. So with frequencies on either side of that maximum being roughly mirror images of each other. So let's look back at the distribution we created above. Here with this distribution, it starts out small, 1, it gets bigger, 2, 3, 6 is a large value, then it starts getting small, 1, but then it starts going back up, so this is not going to be a normal distribution. Something that would be normal, I'm going to just make up some data, make up a data set, so we can see what a normal distribution might look like. I'm going to do this sideways, which you certainly can. So maybe our first class has a frequency of 2, and the next class has a frequency of 4, then 7, and 6, and 4, and 3. This looks approximately normal because it starts off small, it increases to 1 or 2 values in the middle, and numbers on either side, they are approximately equal, so you have this symmetry relative to that middle. So that would be approximately normal. That's how you might identify that from, or try to identify that based on looking at the frequency distribution. Later on, we'll look at more formal methods to decide, is this normal? But for now, that's how we can get a gut feeling. All right, we'll talk to you next time.